Have you ever marveled at how a tiny thermostat precisely controls your home's temperature, or how an anti-lock braking system swiftly responds to prevent skids? The invisible intelligence behind these actions is firmware, a specialized type of software. Firmware for an embedded system is built through a structured software development process that transforms human-readable code into a machine-executable form, specifically designed to operate on the system's unique hardware components. This process involves several critical stages, from initial code creation to final deployment. The necessity of this intricate build process stems from the unique constraints of embedded systems. Unlike general-purpose computers, embedded devices typically have very limited processing power, memory, and storage. The firmware must therefore be highly optimized to perform its specific tasks efficiently, often in real time, and with minimal resource consumption. This means every line of code and every configuration choice must be carefully considered to ensure reliable operation within these tight boundaries, directly impacting the device's functionality and performance. Building firmware typically begins with writing source code, commonly in languages such as C or C++, because of their efficiency and direct hardware access capabilities. This code is then processed by a tool called a compiler, which translates it into assembly language, a low-level representation understandable by the specific microcontroller. Following this, an assembler converts the assembly code into object code, which is essentially machine code for individual source files. Finally, a linker combines these object files with necessary libraries into a single executable binary image. A crucial concept in embedded firmware development is the tool chain, which refers to the complete set of programming tools used to create the final executable. This typically includes a cross-compiler, an assembler, a linker, and often a debugger, all specifically configured for the target embedded processor architecture. This cross-development environment allows engineers to write and compile code on a powerful host computer for a much less powerful target device. Understanding the memory map of your specific microcontroller is also vital, as the linker uses this map to correctly place code and data in the device's limited memory regions. In essence, building firmware is a meticulous orchestration of software engineering principles and hardware-specific knowledge. It is about crafting highly efficient and reliable code that perfectly marries with the underlying electronics, allowing our everyday devices to perform their intelligent functions seamlessly. This foundational process ensures that, from a simple sensor to a complex industrial controller, every embedded system can execute its predetermined tasks with precision and dependability.